Hi everyone. Thanks for sticking around. My name's Mathis Baumert. I'm going to give a little um, presentation into regular expressions. It's not going to be too long. I think it says 20 minutes. I'm not even sure if I'm going to take that long. I was supposed to be there in person, but basically after the date was set, then realized actually I'm on holiday. So that's why you probably can see the video or so, and in the background you can see our beautiful caravan that we're in right now. And the wife and the kids are currently in a theme park, so I definitely got the better deal there. Um, so. Um, I am the technical authority for test systems at Abaco Systems, which is a defense company which creates ruggedized computer systems for the aero market. And I am the technical lead there for the test automation team. And our team has very recently been audited and awarded to be a NI Center of Excellence. And we were the first in the UK, and to my knowledge, we are also still the only ones in the UK. Correct me if I'm wrong there. But that's basically basically what our team is. We have currently 4 people in the team. 3 of those are CLAs. 2 of those are CTAs, 2 of those are CTDs. So we take the whole certification route also quite serious. And as you can see, I also have one of the few ones that, in addition to the architect icons, I also have a Center of Excellence icon. Yay! So let's get going. The first thing that I would like to do is do in our Giants Are Female slide. So the person that I would like to talk about is Evelyn Berejin. I'm probably just absolutely messed up that name, and she would probably turn over in her grave. So she is an American woman who's basically an entrepreneur. She very quickly realized that as an employee, she simply couldn't do what she wanted to do. So she became independent, started her own company, and she created a machine which in essence was the first word processor. So basically you can see the machine there in the background, and it stored the text to a magnetic tape and could play it back, and you could modify it. And so that is basically the first prototype of Microsoft Word that you are seeing there. So which I think is pretty damn important. She's also done loads of other stuff. She was one of the visionaries, and I'm pretty sure had she been a man, she probably would have been one of the billionaires. Like she's created like a booking system for airlines, so airline booking system, which had like a response time of 1 second and not a single major downtime in over 11 years. She created banking systems, so she was all over the place, and there were some really funny anecdotes, like this word processing machine, when they were demonstrating it to the press, it had problems when the air was too dry. It would spark, and basically you would get short circuits in the dusty air or so. So what she did was she took a bucket of water and tipped it onto the carpet, so that for the demonstration everything went smoothly. So there is a BBC article about her if you want to read a little bit more, but I find her pretty impressive. So going on about regular expressions. So we at Abaco we have we are testing mostly computer systems, and we're mostly testing them by running test scripts on an operating system which runs on our UUT, and then we interface with that. We have to basically read back the text output and have to interpret that and have then to decide, like, yeah, this is a pass fail. So from a test perspective, this is very much like you would run a memory test on your own computer. So these outputs can be more or less complex. And I would like to start off basically with one of the more complex ones, which is this. I don't know, you can probably not see that much of it. Let me just see if I can zoom into this a little bit. Just the, so we can basically, this does obviously hasn't blown up the resolution, obviously. So we can see what basically like loads of weird combinations with brackets and stuff. And this is because the actual test here runs in a user interface, which on a VT100 interface. So we get loads of VT100 escape codes, which are basically deciding things like, what is the text color? Where is it going to be? Is it flashing? What is it going to be? But it really creates a big problem. So this is a legacy system, obviously. So this testing, automated testing has never been taken very serious in the company because we are like a low volume, high value industry. And so automated testing was simply not deemed that important. But out of a sudden, the volumes are ramping up now, and it's really, really biting us in the back. This lack of foresight 10 years ago or so. So we are at the moment using teststand to try to automate all of this. And then we get output like this. And what we have to get out here, for example, is you see there is like run one, GPIO loop back, and then there is at the end a pass. But this can also go over multiple lines. So for example, if we see here, basically we have run one, BMM, power manager stuff. And then if we actually scroll down, by the way, can you actually see this blown up? Yeah, good. So we see basically, oh, it's actually, I missed it here. You can actually see there is, in the middle of the screen, there is the pass. So we need some kind of method to extract this type of information without, but we need some kind of method to extract this type of information. Let me just see if I can actually get rid of this magnifying thing now. Okay, that's right. So, and that is not actually that simple. So we have a few options, obviously. So let's actually, we'll come back to this example a little bit later. But for now, let's look at actually a much simpler example. So this is basically an example, and it's a problem that we all face. We all want to be a potato. So as you can imagine, who wouldn't want to be a potato? So we would have something like where we have a shell output, and here is an output that tells us actually if we want to be a potato. So how do we find out basically if we want to be a potato? So the simplest way of doing this would simply be a search and replace, where we're obviously not actually replacing anything. We're just searching for a fixed string, and then we actually look at the number of replacements. So if that is larger than 0, we know we've found this. It's not a very elegant solution, and I don't actually recommend anyone to do anything like that. But it is there. So a different problem would be, for example, if you have some kind of output that comes back on a serial port or anything, which comes more like in a table form. So for example, here is something 1, 2, 3, 4, 5, 6, 7, 8, 9, and we just want to basically get those out here. So here we actually have now a pretty decent method of doing that, which is like the scan from string, which we get natively in LabVIEW. So here we let's just see if I can. Can I activate the pointer option? Right. So we can here define in the search that basically to look out for integers, and then we can filter those out. We could also just look. We could also look for floating points or just for strings. But the thing where it really breaks down and which makes it difficult to use is that it can't deal with spaces. So you can't just say basically, so going back to our previous example, basically here you can't just say like, oh, just look for the here is some output that tells us if, and then basically afterwards give us the string. That will not work. So it will complain then. I can actually quickly demonstrate this. Right, come on. Come on. Ah. You would think that they give us good computers so that we work effectively, but unfortunately that is just not the case. So we have so if we just copy paste the string here, or actually just this string, because this is already going to completely fail anyway, and do something like this. We just get this in here. We want to scan from string, put this in, and then we'll say something like we take this string basically as the start, and then we'll just look for a string, and I'm pretty sure it will just fall apart. Let's run this. Oh, it actually did something. Ah, yeah, it did actually find the we. So so it did find one thing, which is great, but it doesn't really help us. So we need to basically, for this, we need to know exactly what our sentence is going to be like. So we would basically have to be something like %s space %s. So it's just, if you have some kind of a table, it works very well. If you have some kind of text that you really need to filter out, it's just not the right tool for the job. So match pattern is much better there. So we can use the match pattern. So if we throw this away, the match pattern already, if you actually look, if you already look at it, already has the word regular expression in there. That is not totally true. It is a subset of regular expression, but we'll be going more into what actually regular expressions are in a moment. But basically for now, let's just try this out. If we can just find the string, which I'm pretty sure we will be able to do. If we just do something like that. So this is our string. And let's just rewire this. And we want to find, we want to know if we want to be a potato. Who wouldn't want to be a potato? So if we run this, then we find that string, which is not surprising because this is kind of like one of the simplest things that you can do with a match pattern. But the match pattern, basically, if you actually look at the help file, can do a lot more than that. So let me just get this up here. Come on, LabVIEW help. So the regular, you can use here special. So this function gives you fewer options for matching strings, but performs more quickly than a proper regex search. So there's basically, what you can do is basically you have this subset of functions that you can use. So you can use them for certain digits, you can put spaces in. So those are all things that you can do with a regular expression, but you can do a lot more with regular expressions. So, and that is what we are basically going into next. So match pattern is probably for this task was probably the best thing to do, but for my initial example, it's still pretty useless. So the regular expressions are really basically what we need here. So regular expressions are basically syntax search patterns. They take a lot of getting used to. But what is really great is you can search for basically for submatches. So say like you look for anchors in the text that you want to, that you know are around the content that you actually want. So you can put those in your search pattern, but then you ignore them actually when you're looking at the results. So otherwise you would have had the problem of basically like, I always know that these things are around my search expression. So now I'm putting them in, and afterwards I have to cut them out. So regular expressions basically just immediately remove that problem for you. And LabVIEW supports them. LabVIEW supports the Perl implementation, which is the most common implementation. There is also, I think, a POSIX implementation, but most algorithms basically use the Perl implementation. So if we basically look at the previous example with our 1, 2, 3, basically with our little table, we can now change the pattern basically from this %s, %s, %s to something like this. So the /s, so there you will be working a lot with like escape characters in regular expressions. So and I already have to warn you, in particular, when you're using something like that in teststand, you will come into the very devilish place where teststand is escaping characters, and then the regular expression is escaping them as well. So for example, if you want to have a // for like a network share, the regular expression is going to escape each of those backslashes to //. So out of a sudden you have // And if you pass that, for example, to a code module from teststand, teststand is going to escape each of those again to // So out of a sudden your // has grown to 8 backslashes. So just one to keep in mind, though there is some way around that to at least not allow the escaping in teststand. Right. So back to this example. So the /s is a white space. So simply what we're looking for is, in this case, I've already made it a little bit more generic than I probably would have needed to. So because I'm simply looking, is there anything before and after my search string? So the asterisk tells me that there needs to be 0 or more of these characters. So we are looking if there are 0 or more white spaces in front of my 1. Then I'm looking for digits. And there needs to be, the plus means there needs to be at least one or more. And then after that, I'm looking again for white spaces. So now often in tables which are printed back from a command line, you will have the problem that the application is trying to format that in a nicely human readable form, which means it is not going to have a consistent number of white spaces in between numbers, but it is going to have a certain spacing between the beginning of numbers. So say if we have a spacing of 10 characters between the first and the second numbers, that means if each of my numbers is only 1 digit, there will be 9 spaces in between them. If my my first number is, however, a 5-digit number, then I will only have 5 spaces in between that. So this allows me to actually look dynamically for basically a dynamic amount of white spaces. And I should probably not have, between the numbers, I probably should not have made that \s asterisk. I probably should have made that \s plus, because we do expect at least 1. So if that's not there, we probably shouldn't proceed anyway. Sorry, are there any questions?
Mathis, your time estimation.
Yeah.
So
have I gone over time?
Yeah, well, don't worry, carry on, but I'm just saying that the 20 minutes are up. But
okay, I'll be done in a few minutes then. Okay, so let's move on then. So how do we develop regular expressions? Basically, don't try to do that in LabVIEW. What you should do is go onto a website like regxr.com or regx101. regxr, so basically each of those allows you to drop in a text, and then you can just write your regular expression, and in real time it will highlight you what you are finding. So do that because you have the direct feedback. Okay. So now the submatch function isn't very dynamic, because you need to pull down the thing and basically get each submatch one by one, which, if you want to use it in a generic VI and testent, is not very useful. But you really didn't think that this yellow color actually told you that it was a primitive. I mean, normally it should be, but in this case, it really isn't. There is actually this node does actually call a VI, which you can just call from the VI lib. So, and that has, as you can see, has an array of a 1D array of strings, which comes out there and which gives you the submatches. So, and that way you can create your generic VI. So let's go to, so it can get very quickly very complicated. So for example, for an IP address, you get then all kinds of weird combinations where, obviously, if you have a 2 in front of the number, you know that the second digit can't go up to 9. And so it gets quite long-winded if you want to be exact. So back to our original problem. You see the regular expression there at the bottom, and the problem is solved.
Do you want to minimize that window that appears on your screen? Yeah, thank you.
Right. So that's basically, so that took me, and that's the thing, it looks really, really horrible, but I took this output, put it onto one of those websites, and just started to develop it. And it took me probably half an hour. So, and it's just trial and error, like, right, okay, now I'm getting everything in this test output, but nothing in this test output. Why is this? Okay, I'm too restrictive now. Right, okay, now I'm actually getting stuff which I shouldn't be getting. So it's just a bit of trial and error. But so, as I said, this it looks horrible, this regular expression, but it took me about half an hour. And there are then things like everything which has like the question mark in front in the brackets. Let me just see if I can. So basically here, that means that is being ignored. So we are basically looking here for the anchor, which is here the VT100 escape character. That's ignored. Then we are looking for the run, and we are taking that. So run 1. Then again, the stuff in the middle here gets ignored. Then we are actually taking something in again, and so on and so on. So that's really basically how you are developing those. So yeah, it's good fun. So, but I think, yeah, basically that was it. Yeah, any questions?
Mathis, maybe in the regxr website, do you want to show that cheat sheet?
Oh, yes, of course I can do. So in the regxr website, you basically have here the reference, and then you can go into like things like patterns. No, not pattern settings. Where are they? Cheat sheet. There we go. And there you can basically then see all the different expressions or escape stuff, basically, which you can use. Like, okay, this is not very specific. I'm pretty sure there was something more specific than that. That's just generic stuff. Oh yeah, and oh yeah. So basically, we can go then here, for example, escaped characters, and can then look at those things, or we can look at anchors, which is also very useful. So, for example, word boundary, or the beginning of the line, the end of the line. Character classes, yeah, basically here. All of those white spaces, not white spaces, digits, not digits. So it is fairly, the regexr website is fairly comprehensive when it comes to that. For performance, if you want to optimize your regular expression for performance, I would actually recommend you the other one, because what you get here, let me just copy all of this over. What you get here is that it tells you how many steps it needed. So it basically tells you how efficient your regular expression is. So if out of a sudden you have for a fairly simple regular expression and get like 200,000 steps in there, you may want to go back and see if you can optimize that a little bit, because if you have a lot of these lookups, it will get it will take a very long time.
Yeah, I think regular expressions are a bit of a dark art. So
yes,
like,
they certainly are.
On there and going, oh God, what the hell is this?
Yeah.
I mean, like I started doing like web development where regular expressions are really common for like just doing simple things like validating the email address, and tools like that did not exist when I was doing it, and it was an absolute nightmare. But yeah, the tool's definitely very useful, and yeah, good luck. But
yeah.
Powerful tool, but yeah, it's a bit of a dark art.
But I think, I mean, my experience, it looks daunting, but I think if once you get the idea of capturing group, non-capturing group, and the character classes, I think you can. It's still possible. It may not. I may not come up with the most efficient one. I mean, but which may take some time. But I think it's still something we all should be trying, because. Yeah.
It's a good candidate for like unit testing as well, if you're using like LabVIEW unit testing, so that you can basically feed it a bunch of different variations that you might expect to see, and just check that you are getting out all your matches that you expect.
I think there was like a comment of the famous physicist Richard Feynman, which he said about quantum mechanics. He basically said, we will never fully understand quantum mechanics. We can only get used to it. And I think that's probably very, very true for regular expressions as well.
Yeah, I think, I mean, there was an XKCD which said, I have a problem with string parsing. And then somebody said, use regular expression. And then he goes, okay, now I have two problems.
Yeah, very, very true. Yeah, Sam, for example, also created, that's ages ago when we were still both working at Intelligent Energy, he created like, you know, with compact Rios, you have often a problem that they just lose their IP address, or you can't basically figure out their IP address because it's hard configured or so. So he created like a little Arduino-based device with an LCD display, which basically just plugged into the COM port of a compact Rio and just read out the boot up sequence, and was filtering out the regular expression basically of the IP address, and was basically then telling you, yeah, that's the IP address, and thank you very much, I can communicate with it again. So that was a pretty awesome application of regular expressions.
Any more questions? No. Yeah, no more questions from our side. Anyone online? If anybody's online. All right. Thank you, Mathis. That was brilliant.
Thanks a lot.